Hello everyone, welcome back to your own mathematics channel, asm.geniusjunction. I'm Abhishek Samasar, your mathematics mentor. In today's video, we are going to cover 0606 Add Maths Unit 1 Functions. This is your video number 3 and this video is in continuation with video number 1 and video number 2 which are already uploaded, right? So before going through with this video, I suggest you all to please go through with video number 1 as well as video number 2 so that you can effectively learn what we are going to cover in video number 3. The topic which is going to be covered in this video is composite functions. This is a very important topic from examination point of view and maximum questions are framed from this particular topic, right? So without wasting time, let's start. What are composite functions and how to solve questions based on them? Composite functions. When one function is followed by another function, the resulting function is called composite functions, right? There are three important points to remember about composite functions. The first point says that f of g of x only exists if the range of g is contained within the domain of f. We will discuss this point when we will do the questions in detail, right? Second point says that in general, f of g of x will not come equal to g of f of x. Third point says that f of x means that you have to apply the function f twice. Some of the times it is written as f square times x. So students may get confused. This is actually f of x. We will understand when we will do the questions based on this, right? Okay, so let's move on to the next part of it. Now we have reached on composite function and this is a diagrammatic representation of a composite function. A composite function is formed when the input value x is acted by g of x first. So this is the output when the function g acts on it. And then the output which is given by g is substituted as the input value in f of x. And then what we get is a composite function f of g of x. So in this way we get the function fg. Let's see how we need to solve the questions which are based on this topic, composite functions. Yes, so this is your first question which is based on the topic composite function. So let's start with the solution of it. In this question, a function f of x is given as x square minus 1 and there is one more function g of x which is given to you as 2x plus 3. We can see that both the functions are defined for x which belongs to real number. Yes, so in this question we need to find g of f of 5 and this is to be calculated. So first what I'm going to do is I will calculate f of 5 first. So in the function of f of x, in place of x, let's substitute 5 quickly. So you will get 5 times 5, that gives you 25, minus 1 gives you 24. So now I'm going to substitute this value of 24 in place of this f of 5. So I will write this function as g of 24 and in place of x I will substitute 2 times 24 added 3 and I get my final answer as 48 plus 3, that is 51. So my final answer for the given question is going to be g of f of 5 gives you 51. Okay, so please pause the video, note the solution so that we can move on to next question. Yes, so now we have reached on next question of this video where the function f is defined as f of x and this is 1 plus root x minus 2. It is given that x will always remain greater than 2 or equals to 2. It cannot be less than 2, otherwise function will become not defined. There is one more function g of x which is also stated as 10 over x minus 1 and in this case x is always going to remain greater than 0. Okay, question wants us to calculate g of f of 18. This is to be calculated. So first step which I'm going to follow is I will calculate f of 18. right? The way we have done the previous question, in the same way we will approach this question as well. So let's calculate f of 18. So in the function f of x, I will substitute 1 plus root 18 minus 2. This gives me 1 plus root 16. This gives us final answer as 1 plus 4, that is 5. This is going to become g of 5 now, and this is to be calculated. So in the function, I will substitute 5 in place of x, minus 1 will remain as it is. When I will solve this 10 by 5, I will get 2 minus 1, that is 1. So we can say that g of f of 18 gives 1 as the final answer for the given question. Okay, I hope you are understanding how to make a composite function and then how to solve this. Let's move on to next question of this video. Yes, so now we have reached on again a very important question of this video. In this question, a function f of x is defined as 3x plus 1 and the domain is real numbers. In the same way, there is one more important function g of x which is defined as 10 over 2 minus x. In this case, x can never be equals to 0, otherwise function will become not defined. Denominator will become 0 and denominator 0 is not acceptable, right? Okay, so let's move on to the solution part of it. They want us to solve the equation g of f of x equals to 5. We need to solve this equation. So first of all, I will make this composite function g of f of x. In the function g, I will substitute x with the function f of x. So you can see that function f of x is there written at the top. I will write it in place of x in the function g of x. So this is our g of f of x. Let's solve this first. So I will write it as 10 over 2 minus 3x minus 1. If I solve it further, I will get 10 over 1 minus 3x. So now I have g of f of x, that is 10 over 1 minus 3x, and I need to put it equals to 5. So I will write 10 over 1 minus 3x equals 5. This is going to give me the final answer as 10 equals 5 minus 15x. Let's solve this further. So 15x becomes equals to minus 5 and x gives you the value as minus 1 over 3. So we are getting the final answer as x equals to minus 1 over 3. So this is the final answer for the given question. Please note this complete solution and then we will move on to next question of this video. So now this is next question in this video number 3, where we are solving composite functions, and in this question there is a function f of x which is given to us as x plus 4 whole square plus 3, right? This function is defined for all values of x which are greater than 0. Similarly, there is one more function given over here which is given as g of x equals 10 over x, and again this function is defined for all x greater than 0. Now question wants us to solve this complete expression f of g of x equals to 39. So how we are going to approach this question? Let's solve this. Okay, so I will put g of x in the function f of x. So I will write the function f of x first. Let's write this f of g of x. So I will write, I'm leaving the space for the function g of x. This is plus 4 whole square plus 3. And in place of this x, I will write the complete expression 10 by x, because this 10 by x represents g of x. So you can see that I have substituted this g of x in the function f of x. This is the way we form a composite function. And now we need to solve this further. So question says that we need to put it equals to 39. Okay, so let's solve this further. This is 10 over x plus 4 whole square, and this 3 will move on the other side, so I'm going to get 36. I will remove this square from the left hand side, and I will put a square root on the right hand side. Yes, so in the next step I will write 10 over x plus 4 equals to plus 6, or 10 over x plus 4 equals to minus 6. So these are the two equations which we need to deal. This is your equation number 1 and this is your equation number 2. So we will solve both of them simultaneously. Okay, so let's solve equation number 1. 10 over x, this 4 will move on the other side, so I will write 6 minus 4, that is 2. In the next part it is going to become 10 over 2 equals x, that is x is equals to 5. Okay, so let's solve the other part of this question in the same way. I will write 10 over x as it is. This time minus 6 minus 4 will give me minus 10. 10 over x gives you minus 10. When I solve it further, I get x is equals to minus 1. Okay, now let's move back to the question. Question says that f of x function is defined for all the values of x which are greater than 0, and g of x is also defined for all the values of x which are greater than 0. So let's move on to the solution which we are getting. So in the solution part, I will reject this particular solution because this is not in alignment with the domain which is given for f of x and g of x. So this is my accepted value, and this is the final answer as well. Okay, so please note the solution so that we can move further. Yes, so now we have reached on the next question of this video, and again this is the very important question from concept building point of view. If you will be able to understand this question, it means that you have well understood the concept of composite functions. So let's start. So f of x is defined as 2x added 5, and x belongs to real number and x is to be kept less than 2. Similarly, there is one more function given to us. This is g of x. G of x is given as x minus 3 whole square. Again, x is defined for all real numbers and x should be greater than 3. Okay, so very important part that we need to understand, f of x is defined for all x less than 2 and g of x is defined for all x greater than 3. So let's start with the part A of this question, which is asking us f of x range. So range of f of x is calculated. So we can see that f of x is a straight line and f of x is defined for all x which are going to be less than 2. So I will say 2 times 2 plus 5, that is 9. Okay, since x cannot be equals to 2, then the function f of x can never attain the value 9. So the range of function f of x is to be taken as less than 9. We can understand it in this way that x will always remain less than 2. So function f of x will always remain less than 9. So this is the way we have calculated the range of the function f of x. Now let's move on to understand the range of g of x. So in this part, range of g of x is to be calculated. So as I've already told you, this is a square function, and we know that a square function has minimum possible value as 0. And when you are going to attain this value 0, when I put to 3, and it gives me final answer as x is equals to 3. And the domain is saying that x should always remain greater than 3. Therefore, we can say that range of g of x will always be greater than 0 according to the given situation. Okay, so yes, we are done with the part A, both the first and the second part of it. Now we are moving on to B part, where we need to calculate g of f of x. In part B, we need to calculate g of f of x. So in the function g, I will leave the space for f of x, and then I will put a square again. Now in place of this x, I am going to substitute the complete expression 2x plus 5, which is representing f. Okay, so I have kept f in the function g, and now let's solve this further. So I will write it as 2x plus 2 whole square. You can see if I take out 2 common, I will write it as x plus 1, and this is whole square. Finally I can write it like this in the simplified way. So this is my g of f of x. Okay, now I have calculated the function g of f of x. This was our part B. Now C part says find the domain and range of g of f of x. I'm solving this part C right over here so that we can understand effectively. So first of all, let's calculate domain of g of f of x equals to 4 times x plus 1 whole square. Okay, so when we are solving for domain of the composite function, we need to understand that which function is acted first. So we have substituted f of x in the function g of x. So this is very important that the output of g of x should be contained in the domain of g, right? So domain of g is defined as it should be greater than 3. It means that the function g of x should always have the value of x greater than 3, right? We cannot substitute anything which is less than 3. Right now, the complete function g is having f of x substituted in it. So this complete function f of x should have its value greater than 3 for g of x to be defined. So I will write f of x need to be greater than 3. That means 2x plus 5 is needed to be greater than 3. I am solving it further. I will write it as x greater than minus 2 over 2. That is x should be greater than minus 1. Okay. Also, a very important criteria which we need to understand that for the function f of x, which is defined as 2x plus 5, it is given that x should be less than 2. It means the function f of x should always have its value x less than 2, right? So we will combine the two criterias. This is your first criteria and this is your second criteria. Yes, so if I combine the above two criterias, then I will plot minus infinity over here and plus infinity over here. I'm just representing you how we need to combine these two things. So this is minus 1 and this is plus 2. And according to the situation stated above, x can have all the values which are greater than 1, and x can have all the values which are less than 2, but it cannot have its value equals to minus 1 and less equals to 2. So I will write x is less than 2 and x is greater than minus 1. So this is going to act like a domain of g of f of x. Okay, now we need to calculate the range of the function g of f of x, right? So the function g of f of x will be calculated very easily. First of all, I will put minus 1 in the complete expression, and my expression for g of f of x is written over here. You can see this. I will substitute minus 1 in this, so I will get 0. Now if I write g of f of 2, I need to calculate 4 times 2 plus 1 whole square, that is 4 times 9, that is 36. Therefore, the range of the function g of f of x will be written as less than 36 and greater than 0. So this is going to be the final answer for the given question. I hope you are able to understand how we calculated the domain range for composite function, how we calculated the composite function. Thank you so much for watching this video. The topics which are going to be covered in the next video are modulus functions, operations on modulus functions, and solving modulus functions. So stay connected, subscribe the channel so that you can get effective information timely. Have a very good day. Take care.